Java contains a number of fundamental data types. Here's a complete list of them. Although Java derived from C, the data types are a bit different. For one thing, C doesn't have a Boolean data type or a byte data type. Also, unlike C, the Java data types all have a fixed size. It stays the same no matter what computer system the Java program is compiled and is running on. If you have a C background, you can forget about the int being whatever the native size of an integer happens to be. In Java, an int is always 32 bits long. In Java, when you declare a variable, it always has an initial value assigned to it. If you don't assign one, the system does. Briefly, all numeric values are 0, characters are null, and Boolean values are false. Let's take a quick look at each one of these types. You'll need to know this. A Boolean data type has no specific size, but it is conceptually 1 bit in size, and that bit is either on or off. It can only take on one of the two values, and these values are represented by keywords in the Java language. It can only be true or false. Now, this is not an integer. There is no direct way to convert a Boolean data type to an integer or an integer to a Boolean data type. There are a number of ways to write expressions that result in Boolean values, and these expressions are used in if statements and while loops. A byte is an 8-bit integer value. It can hold the values from -128 to +127. These are the values -2 to the 7th and 2 to the 7th minus 1. A byte is always a signed integer value, that is, it can always contain both positive and negative numbers. A char, or char, or however you want to say it, is a 16-bit value. It can be treated like an integer value. You can do arithmetic on it, but it is intended to hold characters. While you can treat it like an integer, it has a couple of characteristics that no other integer data types have. First, it's unsigned. That means its value ranges from 0 to 65,535. Second, in a Java program, a char data type is always interpreted as the numeric value of a displayable character. It holds the Unicode characters, and we're going to have more on Unicode later. A short data item is also an integer value that is 16 bits long. However, it is a signed integer value. The values range from the negative number 2 to the 15th to the positive number 2 to the 15th minus 1. That's -32,768 to 32,767. An int data item is an integer value the next size up from a short. It's 32 bits in size. Now, this is probably the most used of all the variable types. Its range covers all the values that are required for normal operation. The values range from the negative number up to the positive number. That's the -2 to the 31st up to 2 to the 31st minus 1. The largest of all the integer types is the long data type. It is an integer value that is 64 bits long, and this range is enormous. This range is from the negative number -2 to the 63rd up till 2 to the 63rd minus 1. This range is so large it's almost ridiculous. Just in case it ever comes up, you might like to know the positive value in this range is pronounced 9,223,372,336,854,775,807. To give you an idea of how big this is, the internal Java time is kept in account of the number of milliseconds from midnight, January 1st, 1970. And this number is large enough to number every millisecond for 250,000 years in either direction. A real number is one that has a decimal point. And a float data type is 32 bits long and includes an exponent, which specifies the location of that decimal point. The range on a real number is a bit different than on an integer. Any real number can be set to either positive or negative, so its range is defined as being from the smallest number it can represent up to the largest. The smallest possible exponent is -45, which means there can be up to 45 zeros behind the decimal point, but before the first digit. On the other hand, a positive exponent of 38 moves the decimal point 38 digits to the right. What does come into play is the number of digits of accuracy. There are only 23 bits used to represent the actual number, even though the decimal point can greatly change the magnitude. The other real number in Java is called a double. It was originally called this because the float type existed first, and this one was an extension from the float that doubled the size of the real number up to 64 bits. The number of bits to represent the actual digits was increased to 52, so it's quite a bit more accurate. The size of the exponent was also enlarged, and this has enlarged the range. The range allows a number as small as 324 zeros following the decimal point, but coming before the first digit. And a number can be so large it has 308 places before the decimal point. Since the days of the original float data type, hardware has made quite a few advances. The default now, when you declare a real number constant value, is for it to be a double. In fact, most real number calculations are done these days using double values. The only real advantage to float types is the fact that they are smaller, and if you're storing millions of them on disk, you may gain from the space saved. I'll show you a bit more about these fundamental types in the next lesson.